But your tests, I started grading them. I should get them done this weekend, if at the latest Monday. If you miss the test, the makeup is going to be Monday afternoon, so make sure that you are here and available, please. This section, all right, this chapter, we're starting to talk about functions. We've already talked about function notation a little bit. Remember, function notation is f of x, g of x, h of x. It could be anything. Instead of saying what letter, function is a fancy way of saying y, okay? From now on, we're going to write everything in function notation. For each x value, there is only one y value. If you are asked if something is a function, you're going to be asked a couple different ways. You might be asked in a table, a list of numbers. You might be asked in a function itself. You'll see the different ways that you can be asked the question. But what you need to understand is that something is a function if x does not repeat. All right? X cannot repeat with a different y value. That's where we have to focus and pay attention to. So if you have examples like these first four, it says determine if this set represents a function. What is the only value we need to look at? What cannot repeat? The x. So look at your x values. 1, -2, and 3. Are there any repeats here? No. So yes, this is a function. All right, so look at the next question. I have 1, 1, 1, and 2. Is this a function? No, why not? X repeats, right? What repeats there? Value 1. All right, sometimes you're going to get funny looking charts like this. Some of us don't mind these. Some of us are like, oh, the arrows and stuff confuse me. Well, could I write this as an ordered pair? I could write this as 1, 2, -2, 4. And then 3, 1, right? And again, what's the only column that's going to matter? Is our x's. Is this a function? Yes or no? Yep. I just wrote it as an order pair. Now look at number 4. This is saying that 4 goes with what number? 1. And then it's saying that -2 goes with what number? And 0. So what do you guys notice about our x column? -2 repeats. So is this a function? No. All right. Y can repeat. Yep. X cannot. You'll see why here in a minute. Anybody have any questions? Does that make sense? Okay. All right. From a graph, the way that you can tell. Now, from a graph, you get a picture. Have you guys heard of the vertical line test? All right. Or the pencil test, sometimes they call it. If you have a picture, if you have a graph, and a vertical line intersects the graph at more than one point, the graph is not a function. Let me explain to you guys why that is, okay? So here's my XY chart, right? And then I have a function that looks like this. God bless you, what kind of a line is a vertical line? Is it an X equals or is it a Y equals? An X equals. So think about this. If you have a vertical line, and it only intersects one time, how many x values are there for that specific point? 1. If it touches the function or it touches the line or graph, whatever, like this, more than once, like it does here and here, what do you notice about the x values? There's 2 of them. They repeat. So if you're given a picture, if you're given a graph, draw a vertical line anywhere on it. If it touches the vertical line more than one time, then it's not a function. Does that make sense? And then you could also be given an equation. And this is where you guys got to pay attention. What have we been focusing on the last 2 things I talked about? Lists and with the graph. What letter? X. So here, from an equation, if y is raised to an even power, or if y is an absolute value, it's not a function. So from a list, like an ordered pair, something like that, if x repeats, no bueno. In a graph, if you draw a vertical line and it touches more than once, no bueno. If you have an equation, if y is raised to an even power, or if y is an absolute value, it's not a function. So you could be given questions like this. Every time we talk about this section or whatever, I always tell everybody to circle what letter? Circle the y, because in an equation, that's the only one that matters. It's the only thing that matters here. So in letter, what is that? Is that that's a 1. Is y either raised to an even power or in absolute value? No. So yes, this is a function. Look at 2. Yes or no? No. Why not? Because y is raised, good, to an even power. What about 3? No. Why? I'll say C above. Right? Same thing. And what about 4? Yes. Very good. All right, those are little things we've got to remember. So now we're going to talk about evaluating. What does the word evaluate mean? What? Evaluate. If you're going to evaluate a situation, you're going to evaluate a problem, you're going to find the what? God bless you. You're going to find the solution. You're going to find the answer. When we are evaluating, it's going to say f of a number. What they want you to do with that number in the parentheses is plug it into the function. So in a case like this, we're given 2 functions. Do you see the 2 different functions we're given? How do you know, God bless you, they're different? Because one's f of x and one's g of x. Okay, that's how they're going to note different equations. So in 1, 2, and 3, I'm putting those numbers that are in the parentheses into which function? The f. In 4, 5, and 6, I'm putting that stuff in the g. Okay, so this is super, super easy. So f of 0. So I'm going to take the equation. That is the f function. So what is it? X squared plus 3x plus 1? And they are asking me to evaluate where f is 0. Well, it's f of x. So they want me to take a 0 and put it in where all of the x's are. So you would say, okay, 0 squared plus 3 times 0 plus 1. Well, 0 squared plus 3 times 0 is what? 1. So we're going to answer this question. We're going to say f of 0. When I plug in 0 for x, what do I get out? 1. If you were going to write that as an ordered pair, does anybody know how to write that as an ordered pair? What's the x value used? What's the x value used? 0, comma, 1. Remember, f of x is a fancy way of saying y. Good. All right, so let's evaluate the rest of these. We're going to say f of 1. So again, I'm going to use the f function. So x squared plus 3x plus 1. And I'm going to use 1 for all my x's. So 1 squared plus 3 times 1 plus 1. What's 1 squared? 1 plus 3 plus 1. What's 1 plus 3 plus 1? 5. So f of 1 equals what? 5. As an ordered pair, that's 1 comma 5. What you plug in for x, what'd you get out for y? All right, let's look at number 3. Now what? I'm using the same function, but I'm evaluating using what number? -1. Okay, let's see if that changes our answer here. So in my parentheses, I'm going to have -1 squared because I'm plugging in -1 for x. Then I have plus 3 times -1 plus 1. What is -1 squared? Positive 1 minus 3 plus 1. What's 1 minus 3? -2 plus 1 is -1. So f of -1 is -1. When I plug in -1 to the equation, what do I get out? -1. So your ordered pair, if you were going to write one, was -1, -1. Just so you guys understand where that's coming from. All right, so now how does this change? We're going to do the exact same thing, but we're plugging in 2 into what equation? The other one. So it's -x squared plus 4x plus 1. Guys, what do you notice about this equation? Where is the negative? It's out in front. When I plug in a number here, do I square it first or do I multiply it by negative? You're going to square it first. It's not like this. Do you guys see that? All right, so when I plug this in, this says -2 squared plus 4 times 2 plus 1. It doesn't say -2 squared. It says -2 squared. So what does that become? -4 plus 8 plus 1. What's -4 plus 8? 4, and 4 plus 1 is 5. So G of 2 equals 5. When I plug in 2 into the g function, what do I get out? 5. Okay, so your ordered pair would be 2, 5. Anybody have any questions? All right, same thing happens, guys, when we plug in numbers as in letters. You use your algebra skills. So instead of a number here, what do they want me to plug in? T. I don't know why we always use t's. So I have negative x squared, what was it, plus 4x plus 1? Plus 4x plus 1. So I have negative, well, instead of x, what am I plugging in? So I have t squared plus what? 4t, then what? Plus 1. So f of t equals this. That's it.
Can you write an ordered pair for that?
No. Because you don't have a numerical value.
Why don't you solve the problem?
Because they're not asking you to. They're asking you to evaluate the function using this given value. So here, what would I do here? Everywhere I see an x, I plug in a what? Okay, an x plus 2. So it's negative x squared plus 4x plus 1, right? So I have negative, this becomes x plus 2 quantity squared, plus 4 times x plus 2 plus 1. So we need to simplify. So this is negative. This is really x plus 2 times what? X plus 2. Plus, you guys, this is 4x plus 8 plus 1. All right, so if we're going to go ahead and FOIL this, I have x squared plus 4x plus 4. You guys agree? Plus 4x plus 9. And then what do I do with that negative? So negative x squared minus 4x minus 4 plus 4x plus 9. And then what do I do with all that? Combine like terms. So negative 4x and a positive 4x cancels. Negative 4 and a positive 9 plus 5. So f of x plus 2 equals that. Questions?
Hold on, I got it.
Sure. All right, let's move along. Look, guys, we're going to do the exact same thing. This is a different function. This is h of x, but what do they want us to do with 2, negative 2, and x minus 1? Just plug it in. So I have 10 minus 3x squared. Okay, minus 3x squared. So 10 minus 3 times 2 squared, correct? What do I do first? Square. So I have 2 squared is 4. So I have 10 minus, what's negative 3? Or negative 3 and 4 is negative 12, right? So h of 2, when I plug in 2 here, what do I get out? Negative 2. Good. Evaluate, just plugging in.
Oh, but where did you get the, oh, never mind.
So now I'm going to do the exact same thing, but I'm going to do negative 2. So I have 10 minus 3 times negative 2 squared. God bless you. So I have 10 minus, well, what am I going to do first? Square. Negative 2 and negative 2 is 4. Negative 3 and 4. Do I get the same answer here? Yep. Where do I go back? Okay. Good. All right, one more time. I'm plugging in now instead of x. What am I plugging in? X minus 1. So it's 3 minus, it's Friday. 10 minus 3. And then I have x minus 1 squared. What do I do first? Yep, so 10 minus 3, and then I have x minus 1 times x minus 1. So I have 10 minus 3 times x squared minus 2x plus 1. Yeah? All right, now what? We're going to distribute. So negative 3x squared plus 6x minus 3. And now we combine. What? Okay, negative 3x plus 6x plus 7. Perfect. All right, are any of those algebra skills new to you guys? No. The concept of we're taking this and plugging it in? Yes. Good job, good job, good job, good job. All right, moving along. Does anybody know what a piecewise function is? Anybody seen a piecewise function before? All right, we're going to graph piecewise in the next couple sections, but it's just like graphing lines and parabolas. The only thing that's different is you don't want the whole thing, you just want a piece of it. But when you are given a piecewise function, you are given yeah.
Is it like a system of equation?
Similar. But if you notice here, I'm given two expressions, right? Sometimes you're given 3, sometimes you're given 4, and you're always given this sort of a parameter. So what this is telling us, I have x squared minus 1, and I have x minus 1. I have two different expressions that we're going to use. And depending upon the value that they want me to plug in, that's what I pick which equation I'm going to use to solve. So what the first one says is if you're going to plug in any x values that are what than 0? Less than 0, you use x squared minus 1. If you're going to plug in any values that are greater than or equal to 0, you use x minus 1. Does everybody understand that? So look at the first value that they want you to plug in, -1. Well, where does -1 fall? Is -1 less than 0, or is it greater than or equal to? It's less than, so you're going to evaluate -1 using x squared minus 1. Because the value you want to use falls in this parameter. It's less than 0. So you have -1 squared minus 1. What's -1 squared? 1, and then 1 minus 1 is 0. So f of -1 equals what number? 0. So now I'm going to use 0 to evaluate. Well, now I have to look and say, okay, well, where does 0 fall? Is 0 less than 0, or is it greater than or equal to? It's greater than or equal to, so I'm going to use x minus 1. So I'm going to plug in 0. 0 minus 1 is -1. So when I plug in 0, I get out -1. Let's evaluate now using 1. Well, where does 1 fall? It's greater than or equal to, so I'm going to use this one, x minus 1. So I'm going to plug in 1. 1 minus 1 is, so how would I write my answer? F of 1 equals 0. Perfect. Just getting you guys used to the notation of things. How do we feel? We're okay? All right. I knew you guys would be okay. All right, now we're going to talk about the zeros, okay? We're going to hear a lot about zeros in Algebra 2 Honors. Another way to call zeros would be roots, solutions, or x-intercepts. What does that mean, an x-intercept? It's where the graph crosses the x-axis, all right? A lot of Algebra 2 Honors focuses on zeros of functions. How do you find the zero of a function? It says find where f of x equals 0. Guys, all this is factoring and solving. You have to understand what this question is saying. To find the zeros or the x-intercepts, you find f of 0. You're making f of x or your y value what number? 0. So look, if I make this 0, do we know how to solve this? What would I do to both sides? Subtract 10, okay. So I have -10 equals -2x. Now what? Divide both sides by -2. So x equals 5. If you were going to write that as an ordered pair, this ordered pair would be, well, I got 5 out when I plugged in 0 for y. Correct? If you were to put that on a graph, that would be where the graph crosses the x-axis. It's all, finding the zeros just means make your f of x equal 0 and solve. -10 divided by -2. You got to move it to the other side. All right, so same thing here. We're finding the zeros. That means I make f of x equal to 0. Do we know how to solve this? Yes. If this factors, fantastic. If it doesn't, what do we have to do? Quadratic or complete the square. But lucky enough, this does what? What are the factors of +6 that multiply to give me +6 but add to give me a -5? Perfect. -2 and -3. So what are your two x values? X equals 2, x equals 3. How would you write that as an intercept? 2, 0, and 3, 0. Perfect. Yeah, because it's not y. What are my two answers here? 4 and negative 4, okay? Plug in 0. I have x squared minus 16. Remember, guys, don't just get in the habit of moving it over and taking the square root. Get in the habit of factoring, because when we have anything higher than squared, we could have some imaginaries hidden in there. So I'm just going to go ahead and factor this as x plus 4, x minus 4, all equal to 0. Now you can say equals, x equals negative 4 and x equals positive 4. How do we write that as intercepts? Negative 4, 0, positive 4, 0. Find the zeros. That means we set f of x equals 2, 0. And let's factor it. How many answers should I have here? 3. I know I should have 3 because the highest exponent is 3. What can I take out of x cubed and negative 81x? Take out an x. With x squared minus 81, yeah? No. There's an x along with it. So now what can I do? This is x plus 9, x minus 9. All right, so I have 3 answers here. I have x equals 0. I have x equals negative 9, and x equals positive 9. So how do I write my intercepts? 0, 0, then what? 9, 0, and negative 9, 0. Good. So if a question asks you to find the roots, find the solutions, find the x-intercepts, find the zeros, that just means set the equation equal to 0 and solve it. Again, same thing here. F of x becomes what? 0. So how would I solve this? What do I do to both sides? Multiply by 3, okay. So 3 times 0 is 0. 5 minus 6x, now what? Add 6x to both sides, okay. Or you could subtract 5, either way. And now what? Divide by 6. So x equals 5, 6. Is it okay to get a fraction? Of course. This just means that there is a point, or the graph crosses at 5, 6, comma, 0. Okay? You guys doing great. Find here, example 6 says, find where f of x equals g of x. What do you think I do to this? I set them equal to each other and what? And solve it. That's it. You're just setting them equal to each other and solving. This is understanding what these questions are asking. What would I do in this case? Okay, we're going to add x squared to both sides. What else should we do? Excuse me? Oh. All right, so again, let's subtract the 3x from both sides too. Since this is a quadratic, we just want to move everything over. So x squared plus x squared is 2x squared minus 3x plus 1 equals 0. What should we try to do first? Let's try to factor it. Can I? Are there factors of positive 2 that multiply to give me 2 but add to give me a negative 3? Okay, so x minus 2 and x minus 1 equals 0. And then what do I have to remember to do? Divide both of these by 2. How come? Because your a term is not 1. So this becomes x minus 1 equals 0 and 2x minus 1 equals 0. Agreed? So your 2x values are x equals 1 and x equals 1/2. And how would we write those as ordered pairs? 1, 0 and 1/2, 0. The graph crosses how many places? 2. Again, if you're finding where these two equal each other, you set them equal to. So x squared minus 1 equals negative x squared plus x plus 2. Let's move everything. I'm going to subtract x squared and add 1. So subtract x squared and add 1. 0 equals negative what? 2x squared plus x plus 3. Okay, I don't like to factor when we lead with a negative, so I'm going to go ahead and divide out that negative. When I do that, I have 2x squared minus x minus 3 equals 0. Can I factor this? Factors of negative 6 that multiply to give me negative 6, add to give me negative 1. X minus 3, good. X plus 2. I have to divide both by what? 2 because my a term is not 1. So I have 2x minus 3 equals 0, and x plus 1 equals 0. Do I have 2x values? Yep, x equals 3 over 2, and x equals negative 1. So as ordered pairs, we'd have 3 over 2, 0, and negative 1, 0. How about it? Good? What's next is a blank spot where we have 2 answers. Okay, good, we're done.